here's a formula, or what is also sometimes called a literal equation, and we want to solve this formula for the variable y. And again, solving for a variable means to get the variable by itself on one side of the equation and have that variable term have a coefficient of positive 1. Well, that's what we do when we're solving our linear equations in one variable, isn't it? Don't we get the variable term by itself, isolated on one side, and then make its coefficient positive 1? So the approach we want to take is very similar. I want to isolate the 2y term. Well, right now, it's not isolated. Right now, it has this other variable term, an x variable term with it. So my first step would be to get rid of that x variable term by subtracting 3x from both sides. I can't subtract 3x from 6 because they are not like terms. So I could write that I'm wanting to subtract so that when eventually I find out what x is, I could do the subtraction. And the way we want to write those terms is we typically like to write the variable term ahead of the constant term in an expression. And the way that I do that is by writing negative 3x plus 6. Because isn't 7 minus 4 the same as negative 4 plus 7? 7 minus 4 is 3, negative 4 plus 7 is 3. As long as I maintain the signs, I can rewrite terms in a different order. And that's what we've done here. And now lastly, we want to get the coefficient of this y term to be 1. And we always do that by dividing by whatever the coefficient currently is. And here, I can either leave this expression as it is, or I can perform the division if I will divide both of those terms by the divisor here, which in this case is 2. So I'll take negative 3x and divide it by 2. Well, I can't divide negative 3 by 2 and get a whole number answer, so I simply leave it as a fraction, and I leave it as an improper fraction. And plus 6 divided by 2 will be plus 3. So this is the formula, the equation we create when we solve the original equation for y. We're going to be doing this quite a bit later this quarter with one section of material that we cover. When we cover linear equations in two variables, we will be performing this solving for y numerous times, which is why I wanted to put it here as a way of kind of exposing us to it prior to then. So we've taken the original equation, we've solved it for one of the variables. In this case, we solved it for y, and this is the equation we've produced.